This tutorial is all about how we measure energy changes in chemical reactions. Specifically, we look at fuels and how we can measure the amount of energy which is released when a fuel is burned. At foundation level, you need to be able to describe using a diagram a simple colorimetric method for comparing the energy transferred by a fuel when it's burned, and be able to compare one fuel with another in a fair way. And you'll be expected to know the names of various bits of equipment that you would use in such an experiment, and how to also to make it a fair test. So in terms of this colorimetric method, that means using a calorimeter, which is a copper can. And the copper can would have a fixed amount of water in it, usually 100 cubic centimeters, which weighs 100 grams. You would measure the temperature of that water at the start, and then you would measure a spirit burner's mass. You would light it and heat up the water by a fixed number of degrees, say 30 degrees. You would then measure the temperature accurately a second time to work out the temperature rise, and then weigh the spirit burner, which will have lost mass because it's burned some of the fuel, and from that you can work out the amount of fuel that's burned. That's not so important unless you're comparing one fuel with another. The important thing to realise is that it's the mass of the water which is heated which is important, and the one which appears in the calculations. You get a results table little like this because the measurements that you would make would be measurements of the mass of the burner at the start and at the end to work out how much alcohol has been burned, and you'd also measure the temperature of the water at the start and the end to work out what the temperature rise would be, and you do this for a variety of fuels. You need to be able to calculate the energy transferred by using this formula. You don't need to remember the formula because it's printed in the paper with the physics formulae at the beginning of the paper, where the energy transferred in joules is mass times specific heat capacity times temperature change. And here you'd normally use the mass of water as being in grams and the specific heat capacity in joules per gram per degree Celsius, where we'd use 4.2. You may be more familiar with using 4,200 per kilogram in physics. So here's that formula again. Energy transferred in joules is the mass of the water that you're heating, not of the fuel burnt. It's the mass of the water heated times the specific heat capacity of water times the temperature change. So you might get a student's data like this in an exam question. There's ethanol. We can see that the student has weighed the burner at the start and at the end, and has worked out the temperature at the start, the temperature at the end, but the data is at the moment incomplete. In order for the student to calculate the amount of energy transferred to the water, we need to have the mass of the water, which we're assuming is 100 grams, we'll be given that, and the specific heat capacity of the water, which is 4.2. And we need the temperature change, which we're not given, but we can calculate that because that's the difference between 52 and 22, which is 30 degrees. So using that equation, we can work out the energy transferred is the mass of water, 100, times 4.2 times 30, which is 12,600 joules. Now that's been burned by burning 0.19 grams of alcohol, which is the difference in the mass of the burner from start to finish. So we can work out that 0.19 grams of ethanol has released 12,600 joules of energy. What we then need to do is be able to compare one fuel with another to find out which has released the most energy, either in total or per gram. Here's an exam question. Look at the diagram. It shows the apparatus that Liz uses to compare three fuels. So we've got a copper can or calorimeter with a thermometer in it, a fixed amount of water, apparatus P. The name of the apparatus P would be a fuel burner or a spirit burner. We look at the table, it shows Liz's results. Complete the table. Well, here we're not given the temperature at the start for the ethanol, but we are given the temperature at the end and the temperature change. So the temperature at the start must have been 30 degrees lower than 55, which would have been 25 degrees. Now Liz burns 1 gram of each fuel in order to perform a fair test. Which fuel gives off the least energy? Well, that would be the one with the least temperature change, and that one therefore would be the ethanol. And it would give off the least energy because it has the smallest temperature change. Burning fuels is an exothermic reaction. What's meant by an exothermic reaction? This is a reaction which releases energy to its surroundings. So here's the answers. The piece of apparatus was a burner or spirit burner. The initial temperature was 25 degrees. The fuel, which is the one which is the lowest amount of energy, is ethanol because it gave the lowest temperature rise. And an exothermic reaction is one where energy or heat is given out or released to the surroundings. Here's another question. It says Zoe and Olivia test 3 fuels. Look at the diagram. It shows the apparatus they use to measure the energy given out by the fuels. And again, it's a familiar apparatus with 100 grams of water in a copper can. The name of the apparatus X would be a thermometer. So look at the table, it shows their results. Well, the meths, propanol and petrol are the 3 fuels, and if we calculate the temperature of the water at the start from the temperature of the water at the end, we get a difference of 20 degrees in each case. So it has been a fair test, but the mass of fuel burned in each case is different. So which fuel gives out the most energy for each gram of fuel used? The one which gives out the most energy per gram of fuel used would be the petrol. And the reason for this is that less fuel burned for the same temperature rise. And here's the answers. The piece of apparatus was the thermometer. The most efficient fuel was the petrol because the least fuel was used and it gave the same temperature rise.